Your MCP server just asked for user input, but your terminal is sitting there silent. How do you actually respond to interactive prompts? You'll see exactly how to implement an elicitation handler that catches server requests, displays them to users, and returns properly structured responses. The pattern handles everything from simple text input to complex validation, all while keeping the conversation flowing naturally. From FastMCP import client. From FastMCP client elicitation, import ElicitResult. Async def basic elicitation handler, message, SDR response type params context. Print F server asks, message, hash simple text input for demonstration. User response equals input, your response. If not user response, hash for non-acceptance, use ElicitResult explicitly. Return ElicitResult, action equals decline. Hash use the response type data class to create a properly structured response. Hash FastMCP handles the conversion from JSON schema to Python type. Hash return data directly FastMCP will implicitly accept the elicitation. Return response type, value equals user response. Client equals client. My MCP server, Pi. Elicitation, handler equals basic elicitation handler. This demonstrates the interactive elicitation pattern for dynamic user input during tool execution. The concept enables servers to pause processing and request structured information from clients on demand, rather than requiring all parameters upfront. What makes this distinctive is its ability to bridge the gap between automated processes and human-in-the-loop decision-making without breaking the execution flow. The pattern works through a callback-based inversion of control, where the server defines what information it needs, and the client provides an elicitation handler that determines how to collect it. FastMCP handles the schema translation between JSON and Python types automatically, allowing the handler to focus purely on the user interaction logic while maintaining type safety. This separation of concerns keeps the server agnostic about UI details while ensuring responses match expected structures. This approach solves the problem of rigid input requirements in automated workflows, enabling tools to adapt to missing or ambiguous parameters at runtime. It's particularly valuable for complex operations where not all inputs can be predicted in advance, such as file system operations, data analysis parameters, or approval workflows. The trade-off is slightly increased complexity in client implementation, but the benefit is significantly more flexible and user-friendly tool interactions. Let's break it down. From FastMCP import client. From FastMCP client elicitation, import ElicitResult. Imports client for connecting to FastMCP servers and ElicitResult for structured user responses. These are the core components for handling AI-driven user prompts and returning properly formatted data. Async def basic elicitation handler, message, SDR response type params context. Print F server asks, message. This defines the elicitation handler callback, FastMCP's mechanism for interactive user prompts. The function receives the server's message and must return either structured data or a decline action, enabling human-in-the-loop validation when AI needs clarification. The print statement surfaces the server's question to the user, bridging automated workflows with manual oversight. Hash simple text input for demonstration. User response equals input, your response. This captures user input for the elicitation response. The simple input call demonstrates the basic interaction pattern, though real implementations would replace this with a GUI or API integration. It's the minimal viable way to collect the user's answer to the server's question. if not user response. Hash for non-acceptance. Use ElicitResult explicitly. Return ElicitResult. Action equals decline. This handles empty user input as explicit rejection. By returning ElicitResult, action equals decline, it signals non-acceptance to the FastMCP server, preventing silent failures when users submit no response. This pattern ensures clear communication between client and server during interactive prompts. Return response type. Value equals user response. This constructs a properly typed response using the provided response type data class. FastMCP automatically converts this to the expected JSON schema, ensuring type safety between Python and the MCP protocol. The implicit return value signals acceptance of the elicitation request. Client equals client. My MCP server, Pi. This initializes the FastMCP client, establishing a connection to the server defined in my MCP server, Pi. The client handles all communication between your local code and the MCP server, routing elicitation requests to your handler function. This is the central entry point for integrating with FastMCP's interactive protocol system. FastMCP elicitation pattern. The handler bridge transforms raw user input into structured responses while maintaining protocol compliance, with FastMCP automatically converting between Python types and MCP schemas. Returning data directly implies acceptance, but explicit ElicitResult gives you control over decline and cancel actions. The response type parameter is your contract. It defines both what the server expects and what the client must validate.
The handler that knows nothing of schemas becomes the perfect schema translator.